These are the solutions to 11.3 on page 307. Before you do these, there's just a few guidelines. Ask yourself, first of all, how many slots do you need to fill? For example, if you're picking a 4-digit code for your locker, you have 4 slots to fill. How many options are you given? If you're picking a number for your locker, you can pick a number between 0 and 9. So that's 10 options that you have. Are there any restrictions? For example, you can't start with 0. That's a restriction. Are you allowed to repeat digits or letters? Would it be acceptable to have a locker code of 1111? So can you repeat is a very important factor. And the other thing I will say to you is show your workings. I am going to teach you now how to show your workings. So even if you don't get the completely right answer, you will have shown the examiner that you are going in the right direction. For example, there you can state your assumptions. Now, question 4 is the first one. Question 4 is done. Question 6. A company has 20 members on its board of directors. How many different ways can the members elect a president, a vice president, a secretary and a treasurer? Okay, so we have a president, a vice president, a secretary and a treasurer position to be filled. 20, any one of the 20 could get the first job. Once they've got it, you have 19 people left for the second job, 18, 17, and when you multiply those out, you get 116,280. The next question I asked you to do was question 8. A baby presses 6 of the 10 numbers 0 to 9 on a phone pad once each. Okay, so there is no repetition. So the baby presses, there are 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 possibilities that can go into that first slot, any one of those numbers I just said. Once we've used one of those, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that turns out to be 151,200. And just remember that between 0 and 9 there are 10 digits. The next question is question 10. A company wishes to introduce an identification number for each employee. Every number consists of 4 digits, the first digit of which must never be 0. How many different numbers are there if digits may be repeated? So that's a new thing now. You can't have 0 in the first position, so you have only 9 choices. And the 9 choices are 1, 2, 3, 4, 5, 6, 7, 8, 9. Once you have put in 0 there, you can pick any number again. You're not limited to leaving out the number that you picked for the first slot. So you have 10 choices for the second one, 10 choices for the second one, third one, and 10 choices for the fourth one. So 1 digit has been used. So back to 10 digits, 10 choices there in the next slot. Question 12. In how many ways can the letters of the word modal be arranged? I didn't leave enough space for that, sorry now. So it's 5, 4, 3, 2, 1. That's 5 factorial, as I mentioned in the last video. In one of the examples there, I think it was 11.6. And that gives you 120. Now, there are some restrictions here. How many begin with the letter L? So L must go in the first slot. So modal, M-O-D-A-L. L is gone. I have M-O-D-E, which go in here. Could go in here. Say I put M there, I'm left with O-D-E for this one. Say I put D here, I'm left with O and E as choices here. Put O there, I'm left with E as a choice here. I should have said A. Okay, so multiply those out and you will get 24. Now, part 3. How many do not begin with L? Well, we found out that 24 of them begin with L. There were 120 of them altogether, so 120 take 24. 96 do not begin with L. Part 4. How many may end with M? Okay, so I put M in the last slot, so that's 1 there. So 4, 3, 2, 1 multiplied by 1 gives you 24. Question 14. Karen has to study 7 subjects for her Christmas exams. and she decides to study 4 of them on a particular day. So I gave her 4 slots here. How many different combinations can she have if there are no restrictions? Well, she can pick any one of the 7 subjects here. Then she's down to 6, down to 5, down to 4. So she's 840 possible arrangements. If she must start with maths, so I put maths in here, she has no choice, so that's a 1. She had 7 subjects. 1 is dealt with, that's maths. So she's left with 6 choices here, 5, 4. So that gives you 140 choices or possible arrangements there. The next one is if she must not start with maths. Okay, that gives her 6 other choices there in the first slot. Maths, not one of the subjects is gone, it's not maths. You're left with 6, 5, 4. Now, notice that, yeah, that's fine. Then the next one is she must start with a language. Okay, I've picked out 3 languages there, French, English and Irish. So one of the 3 of those must go in the first slot. That's 3 choices. Once one of them has gone in, she's left with 6, 5, 4, giving her 360 possible arrangements. The next one is question 14. If she must not start with a language. Now, this one here is 840 possible arrangements. And here is if she must start with a language. So that, take that, should give me the answer here, which it does, which is the answer for must not start with a language. Or I can get it this way. Put in the 4 non-language subjects there. 6, 5, 4. And that's wrong at the back of the book because he did that, take that, equals that. That wasn't everything. That should have been 840. Now, question 16. We are looking for a password for a computer. 3 different digits followed by 2 different capital letters. Okay, so there are 10 possible digits. And it says different. So there's no repetition. So that's what I'm just checking there. So 10, 9, 8 will give you the 3 digits, followed by 2 capital letters. Well, there's 26 letters. You've used 1 here. You're down to 25 here. So multiply all that out and you get this number. Question 16, part 2. Ian forgets his password, but he knows that the first number is 5. So there's 1 choice there. And he knows the last letter is A. So there's 1 choice there. He's down now to not picking from 9 digits. And then he's down to picking from 8 digits here. He has used the letter A, so he's down to 25 letters here for choices. Multiply that and you get out 1800 possible arrangements. Question 18. Triangle has to be rearranged with no restrictions. Triangle has 8 letters, so 8 factorial. So you can write it like this and just put that into your calculator. If the n of the triangle must come first, 1, n must go there, so that's 1 choice, and you're left with 7 of the letters to choose from, giving you this number here. 18, part 3. They must begin with a vowel. Well, in my opinion, there's 3 vowels, so I, A and E must begin with a vowel. You use one of those there. So instead of having 8 letters to pick from now, you have 7. Then you have 6, 5, 4, 3, 2, 1 and multiply those out and you get that answer. 6, part 4. If the 3 vowels must come at the start. I've put in the 3 vowels at the start there. You have a choice here of I, A and E. Say you put I there. You're left with A and E. Say you put A there. You're left with E. So there are your choices there. Now the 3 vowels are taken care of. I now have 5 letters left. 5, 4, 3, 2, 1. You can also write this as 3 factorial, 5 factorial. Question 20. You are rearranging the letters of the word piglet. Now piglet has 6 letters. So So 6, 5, 4, 3, 2, 1. Whoops, I should have multiplying signs put in there. And part 2 of question 20. If the arrangements must begin with a vowel, well, I and E are the two vowels, so I've put in two choices there. My two options, I and E. And then once I've used I or E, I'm left with 5 letters, 4, 3, 2, 1, as we did before. Part 3. If the arrangements must begin with a vowel, so that's I or E, and end with a T. T is only one letter, so that's a 1 choice. And I've used a letter there, I've used a vowel there, so I'm down to 4 letters. And 3, 2, 1, giving me that answer there. This is 20 part 4. If the vowels must be together at the start. Okay, I've put the vowels together at the start there. You either put I here, E there, I there. So that's that taken care of. And once I've used those vowels, I'm down to 4, 3, 2, 1 letters. And sorry, I should have multiplied, put in there and in there to get that answer. Now, question 20 part V is more challenging. You want to get the two vowels together. Okay, and I think this is just probably the most difficult thing in the chapter, but it's still manageable if you apply logic. Question 20. Part V. If the two vowels must be together. So the two vowels could be together anywhere. It was easier if they were together at the start. They could be at the start. They could be the second and third letters. They could be the third and fourth letters. They could be the fourth and fifth letters, or they could be the fifth and sixth letters. So let's try this first of all. Put the two vowels here, and then you're left with 4, 3, 2, 1. Put the two vowels here. You have two choices there, I and E. You have one choice here, the one you didn't use. And then you're left with 4, 3, 2, 1. Put I and E here. 4, 3, 2, 1. Put I and E here. 4, 3, 2, 1. Put I and E here. 4, 3, 2, 1. And again, I forgot to put in these. Multiplying. So that now, go back to factorial just because this might be easier for your multiplying. That's 2 factorial. That's 4 factorial. Put that into your calculator, you get 48. Or you could go 2 3s 6, 4 6 is 24, and 2 24s is 48. So, but all these turn out to be 48. So add them up. Because you could have this option, or this one, or this one, or this one, or this one. And when you hear or in permutations, add. Question 22, which is the last one there. How many different numbers with 3 digits or less can be formed from 4, 5, 6, 7 and 8? I've coloured 5 and 7 there because they are odd. Okay, how many different numbers with 3 digits or less? Now that's a bit of a change. So 3 digits, I have 5 choices here, 4 choices here, 3 choices there. What if I had 2 digits? I'd have 5 choices and 4 choices. What if it was a 1 digit I was picking? I have 5 choices. And that's or again, giving me adding. So that gives me 85 different possible numbers of 3, 2 or 1 digits. How many of those are odd? I have 2 odd numbers. So put a 2 there, a 2 there, and a 2 there, because the number, if it's odd, must end in an odd number, which is 5 or 7 in this case. Now, I've used 5 or 7 there, one of them, so I'm left with 4 numbers. 3 and then 2 is at the end. I've used the 5 or the 7 here in the second one. I'm left with 4, 5, 6 or 8 if I've used the 7. And here, if I use the 5 or the 7, I have to use the 5 or the 7 because they're the only odd ones. Add those up and 34 of those numbers are odd.